So here I have some cheap buck converters from Amazon. I think I got 10 of these for like 15 bucks. And I'm just going to be pushing it today to see how far basically they work. This is a 2 ohm load right here. I have 3 6 ohm loads in parallel. I've measured it and I have 30 volts at 0.48 amps going in here right now. And right now I'm measuring across the load, which gives me the voltage, so you can find the power. And the current coming out of this right now is 2.5 amps. And right now it's delivering about 13 watts to the load. The power supply is supplying 14.7, so it's about 87% efficient. And it's barely even warm to the touch. Let me show you this without a heatsink though. There it is with a heatsink running at its rated 2.5 amps. About. Alright, so here's one of those buck converters without a heatsink, and it's probably heating up already a little bit. Makes noise, it's kind of weird. I'm only passing 3.2 volts through it though, so much less power. Let's turn it up. Better not cook itself. So we're going up to 2.5 amps, which is 5 volts. Ooh. There you go. 5.1. So now we're supplying 2.5 amps across this 2 ohm resistor. We're drawing a little bit more power, that's for sure. Let's see how hot we're getting. Oh. Oh, it's going up. So the diode you gotta look out for. I've actually seen them desolder themselves before. Alright, that's getting hot. Alright, so yeah. Maybe for surge situations, but I definitely wouldn't trust this in any kind of project. So now, let's take this one and see how much current I can put through it until I feel uncomfortable about cooking the chip. You can see as it heats up, it actually gets less efficient as the diode, because of the VT constant. That took semiconductors a long time ago, but hot diode bad. I'll actually crunch the numbers. Wow, it actually got up to 160. I saw 160 on there. It wasn't, don't run this at 2.5 amps with no heatsink. And its efficiency went down to something like 71%, which means it was dumping like 5 watts through this little board, which is a lot. Alright, so I've had it pumping out to 2.5 amps for the last couple minutes. Power draw completely stable, 48 milliamps for 480 milliamps. And you can see the temp not even above 90. No, it's very low. But if I turn this up to 7 volts, I'll be pushing 3.5 amps through, which is a whole amp more than what's rated. So let's see how that goes. This is the voltage across the resistor, so you know the resistance isn't changing, you know the voltage, you know the current. So that's 3.5 amps right there. We're drawing considerably more power, almost a whole amp. That's 0.912 amps at 38 volts. It's nearly 30 watts. The load's seen about 25 watts, so that's about 5 watts of power being dissipated into the heatsink. And see if it's getting hot. Seems alright so far. Let's wait a bit and we'll tuck it with the temp gun. Alright, it's been about 2 minutes and the power draw is still stable, but it's still this diode right here. I bet if you replace this diode with a better diode or put a heatsink on there, this whole system could work a lot better. The diode seems to be the bottleneck though, because this is the blocking diode for the buck converter. And you can see we're getting up to, oh, I don't know, 120, 140, did I see that? It's getting hot. So it could definitely handle this in a surge situation if it needed to bump out 3.5 amps. You could probably push it even higher, maybe 4.5 amps in a surge situation, but I don't want to destroy my buck converter. So I paid like 37 cents for this. Now my power supply is even getting hot. Turn the fan on right there. Anyways, also cool feedback network. If you were driving something and you had some thermistors, you put a thermistor on the diode. Ow, yeah, the diode's really hot. Okay, we'll turn you down. But anyways, yeah, you put a thermistor on the diode, I'm sure you could actually read the temperature, and when it passes a certain threshold, it'd probably create that runaway power draw effect we saw earlier, and you could then basically lower the input voltage or the signal so it draws less power long before anything bad happened, like chips started melting or desoldering. I mean, I've had one of these diodes desoldered before. It's a pretty good safety margin, but anyways. All right, hope that was helpful. Have a great day, everyone.